Welcome to explainer video number 4 in our series of exploring the rules of exponents and how they've come about. This next one is an interesting one. A to the power of 0 is equal to 1. There's a couple of ways that we can kind of see why this rule works. The first one is, suppose we have a to the power of 3 divided by a to the power of 3. Using the logic that we used for the division rule, this is the same as a times a times a divided by a times a times a. So this is a scenario where all the a's get paired up, right? So this is then just the same as a over a times a over a times a over a, right? Each of these ends up being a 1. And so you just have 1 times 1 times 1, which is 1, right? But if we use the division rule that we explored in video number 2, a to the 3 divided by a to the 3 is the same as a to the 3 minus 3, which is equal to a to the 0. So these results must be the same. Another interesting way to look at it is, suppose you have a to the power of 8, right? A simple equation says a to the power of 8 is equal to the a to the power of 8. No debating that. If I times it by 1, do we agree that this equation is still true? Of course it's still true, right? So the question is there an a to the power of something that I can multiply a to the 8 with, such that the answer will still be a to the 8. And if we use our rule of the first rule that we learned, we know that if we add a 0 to that exponent, that'll still be 8. And using that rule, we know that this is the same as a to the 8 times a to the 0, right? So that tells us that the mystery number over here is a to the power of 0. If I multiply a to the 8 by a to the 0, my answer is still going to be a to the 8, according to this. And so that tells us that a to the 0 must be the same as 1.